Is voice clear? Actually, rain stopped now, but lightning going on. Voice clear? Okay. I will do one thing. See, some principles are there. I will start and consider that UDL question. By chance, if it runs very heavily rain, I will stop the class. Because even now, lightning is going on. We don't know rain. Any time it may come once again. Suddenly it will come. Okay, at least I thought finish as much as possible. Okay. See, first, an important note. You make a note. I'll do one thing now. I'll see the first screen up to where I can write. Afraid to put mobile in the pocket because comment will be blocked. This line visible? Okay, I'll manage within that line. Now, first make a important note. See, first I write our class question. Today's class question. Today's question is, I will first give by words a simply supported beam of span L. Those who are interested should write it. I will write somewhere here. Simply supported beam of span L. Span L here, loaded by UDL over the entire span. Very important. Underline that one. Loaded by UDL over entire span. Intensity is small w per unit length. Unit length. I will call the beam AB, span L. Find maximum slope theta and maximum deflection. Then I will go to next question, numerical, where I will tell you some very important concept. Okay, start. First, make a note. Neatly put the beam. Start solution now. See. Or you can do one thing. Somewhere in between, make a note. This is the beam. See. Only one color today, no multiple color. This is the beam. I write double line just to show that beam looks like beam. Okay. Reaction here, reaction here. UDL of intensity W per unit length. 1 minute now. Top of board visible? Forgot to ask. Top of board visible? Okay. Top of board visible? No, top of board, is it visible? Okay. Now, what? This is A, this is B. Span is L. See, as usual, span L. What we want? We first want bending moment diagram. See, make a note. If the reaction is VA here, reaction is VB here, you first write due to symmetry, reaction VA equal to reaction VB equal to total load on the beam divided by 2 equal to W into L is the total load divided by 2. So go back and enter WL by 2 and WL by 2. Okay. Now draw BMD. Bending moment at A equal to 0, look this side, equal to bending moment at B, look that side. Then only two standard points, but be careful, A0, B0, so don't join. You have to join by a parabola. Why? Second degree parabola. Therefore, somewhere in between there is a important point where shear force is 0 and bending moment is maximum. You don't have to worry it. You know it. Tell where. You don't have to worry about now all the things. You worry SFD BMD. Left corner. Okay. I slightly shift the camera. Okay. Okay. Now. Now okay? You don't have to worry because that is in SFD-BMD. When you go for SFD-BMD, everything told. See, right, we know that shear force is 0 at center. Therefore, where your BM will be maximum. Center, say C. Mark center C. At what distance? At L/2 from here. Then, bending moment at center C, sagging positive. Look this side. Equal to plus WL/2 into L/2 minus W into L/2 is the total load all over in SFD-BMD into half of L/2. WL square by 4 minus WL square by 8, it will come plus WL square by 8. Therefore, the bending moment diagram will be 0, 0, center is WL square by 8 joined by a parabola. This all known. Now, make a note, all these are not required. This is, you find reaction, but because for simply supported beam, you don't have to bother. People will directly write the answer. See, no need of any calculation all. I will put span L here. Span L, I will mark here. Okay, I want some space there. L. Directly, see, you directly draw BMD. 0, 0, maximum at center, that is WL square by 8 joined by a parabola, second degree parabola. Why parabola this way? I all told earlier. This is the bending moment diagram. Okay, now you don't have to write anything first of all. Now, one very important moment area method, we want properties. So immediately, either here or somewhere, see, this distance is L/2. This also is L/2. This is center C. This is A. This is B. Now, one important note you have to make. See, go back once again. In case I take a section XX, see, now very important. Make this note. I will not tell again and again. See, if I take a section XX at X from here, then bending moment at XX, that is mx equal to plus WL/2 into X minus W into X into X/2, W into X into X/2, or directly X square by 2. Second degree parabola. When you put X equal to 0, see, here, when you put X equal to 0 at A, your BM becomes 0. When you put X equal to L at B, BM becomes 0. 0. And when you put X equal to L/2, BM becomes WL square by 8. So it is a bending moment diagram like this. Clear now? Fast. These are all important concepts. So many people sometimes make mistake in the curve. Okay. Now, see, if it is straight line, triangle. See now. Long back for cantilever, see, your BMD was coming this way. Remember, if the triangle, it will be like this. See, suppose I call base, now see, don't worry about this one now. See, now here, if I consider the curve is like this. Everywhere if I call base B, height H, height H, height H. Area of the triangle is half into base into height. Tell me, this area is more than triangle area or less than triangle area? This comes for cantilever. This area is more than triangle area or less than triangle area? First, this, the middle one, it is lesser. So here area is less. See, if you put this way, half base into height. So this area equal to what? Area equal to 1/3 base into height. This we already considered earlier in cantilever. Tell yes or no? Even I derived also there. If you remember, I derived also there. How it came? Remember it? When I was doing cantilever, I derived it. How 1/3 base came? Remember it? I derived and got the answer. Tell me yes or no. It was derived in the class, not simply formula given. Okay, now, see here. Now, if I join by a straight line here, this is triangle. Tell me. So, this area is more than triangle or less than triangle area. The simple support BMD area, is it more than that area of triangle or lesser? That area for the actual simple support beam, it is more. See, this is 1/2 base into height. This is lesser, this is more. Remember, area of this parabola, area bounded by this parabola and base is actually 2/3 of base into height. Tell me, remember, it is more than the triangle and this is lesser. It is 2/3 base into height. Clear? Now, one condition is there. See, 1 minute. In YouTube, under the chapter mathematical concept, I uploaded 3 classes. 4th class I long back recorded. Around 2 hours class was there regarding how to find area bounded by the curve for simply supported cantilever all. I derived everything there. But due to some problem, it was not uploaded. Now I will upload it now. So I am not going to prove here. Believe me. You can always believe me. So therefore, now remember, this area 2/3 base into height has got a condition. So I will do one thing now. I will write all the conditions here. So many people, they ignore this condition. Then they are making mistake. See again, blunders. See. Now, very, very important note. Simply supported beam. Only simply supported beam. UDL over entire span. Entire span. Entire span. Remember, no partial UDL. And no other load. No other load. You should not have any other load. If any other load is there, equation for BM will change. Only and only UDL. That is, only and, you should write it, only and only UDL, that too for entire span, no other load. That is, rule is that it should be like this. Nothing else. W per unit length. No point load, nothing. BMD will be like this. This is the BMD. Okay. This ordinate, you can remember, WL square by 8. Span is L. Span is L. Now, this is L by 2. This is L by 2. I will take the point as A here, B here, and center is C. Somewhere here C. Now, sometimes you may require the full area. Sometimes you may require half the area. So remember now, conditions are there. Now, one case, consider entire area of BMD, that is end to end, that is for length equal to L, that is A to B. See, I will consider the full area. It is like this. This way. Okay, now, this full area I want. Base is B. Don't take L. Take the base as B, height as H. This H is the maximum height, remember. H is the maximum height. Equal to what? WL square by 8. Anybody can tell me what is the area for this one? Anybody can tell me? Once again, some number into base into height. Or formula is some number into base into height. Height means maximum height. Tell the number. That number. 2 by 3. It is 2 by 3. Okay, remember. This full area is 2/3 of full base into height. Remember, make a note. If you want the full area, it is 2/3 of full base into maximum height. And if you want center of gravity for the entire area, CG will be here. Exactly center. Why? Symmetrical. Tell me. Crystal clear? I am rubbing it now. Crystal clear. Full area is 2/3 base into height, full base into maximum height. Clear? Okay. Now, consider only half the area. Now, consider area from any one of the ends. One of the ends up to center. Very important. Up to center. That is where what? Height is maximum. Height is maximum. That is, see, don't see there. Either any one side. See, this way. This is the height. This should be maximum height. Maximum height for entire BMD. Remember, this is where people make mistake. Maximum height for entire BMD. Base, this is the base. Okay, now, tell the answer. Full area is 2/3 base into height. So, this much here, now, A to C. A to C only. See, this should be center only. No other point. You cannot take other point. Other points are not allowed. You cannot take from center up to here. Ruled out. It is nonsense. People take it mistake. This is compulsory. Compulsory from one end up to center. Tell the area. Now tell the area. Full area is 2/3 base into height. Now tell the area fast. Area. Full area is 2/3. Now, this is half the area. How much answer? Fast, fast. Full area is 2/3. Now, area. Fast, fast. How much? Full is 2/3. See, if you take the full area, it is 2/3 base into height. No, this is the mistake. See, no, how it can be 1/3 base into height? No, it is still 2/3 base into height only. Still 2/3 of base into height. See there, 1 minute. Those people by mistake, I know you gave by mistake. 1 minute now, tell me. This triangle, see, this is the base. This is the height. Area equal to half into base into height. And full this way. Now, suppose you consider only half here, base and height. Tell what is the area? Full area is half into base into height. Now tell the area. Now tell the area. Now tell the area. Full area is half into base into height. For full triangle, half into base into height. What about area now? First, those who typed earlier 1/3, see, mistake. This full area is 1/2 base into height. Tell me what is the area here? Fast, fast. Why this much delay? Tell the area for this one now. Now also half, not 1/4, because now also half into base into height. Earlier this was the base, now this is the base. Half the area base is adjusted in the base. See, earlier 2/3 of L. When you take full area, base is L. When you take this much area, base is L/2. So that will take care of half. Clear now? Clear or not? Clear? Because you typed 1/3. It is not 1/3. Even now it is half only, 2/3 only. Clear or not? Even now it is 2/3. See, or 1 minute. If you take straight line, it is half base height. It is more. So, irrespective of, you write, see, irrespective of full span considered or half the span. Half the span means not somewhere here. Half the span means from one end up to center. Any one end up to center. Irrespective of whether you take full base or full length or half the length. Half the means not random half. Suppose span is 10 meter, not 5 meter in between. Either the full or from center half one side. Whatever you take, area is still equal to 2/3 of base into height only. Clear? But in the base, if you take full area, your base becomes full span. If you take half the area, base becomes half the span. So the area ejected there. So formula is still what? 2/3 base into height. Fully clear? Area is full, still 2/3 base into height. Clear or not? Fast. Irrespective of what? You can make out. It can't be 1/3. See, this area, how it can be 1/3? This is half base height. Clear? Okay. Now, usually in the colleges or offline class, I tell full area is 2/3 base into height. I will tell the students half the area is, all will shout, sir, 1/3 base into height. Very good. I will solve the problem. When I solve the problem, my deflection answer at center, if you remember, what is the answer? 5 by. What is the answer? At center deflection, 5 by number. You know it. Deflection at center, 5 by. 5 by number. You know that number for UDL. Everybody know that number. 5 by 384. 5 by 384 will not come. Then some other wrong number will come. Then I start wondering, what happened? I will check second time, check third time. Then one of the students will tell, sir, you are playing. I will tell, yes, I am playing. He knows that I will act as if I am getting panic. See, I will behave what? In odd way. What happened today? See, answer is not coming. What is this? It never happened in my class. I think if it happens, I will stop my class. I will start cursing. Then student will come to know there is some technical mistake is there. Then I will tell, be careful. Whether you take full area or only half the area, formula for area is still 2/3 base into height only. 2/3 of respective base into height. But remember, to apply 2/3 base into height, your base should be what? Either full span or one side half span. Remember, either full span or one side half span. Remember, only UDL. That too full span UDL. BM should be WL square by 8. And when you consider area for full, 0, peak, again back to 0. If you want at half the area, 0 to peak, you cannot apply for this one. Remember, you cannot apply area equal to 2/3 base into height for this curve. Wrong. Wherever that height taken, slope should be 0. Here slope is not 0. Clear? That formula for simply support beam, you cannot apply when you want randomly some length from support. Either from this end, you should go up to that end, or from one end, you should go up to center. Should not stop in between. You cannot consider what? This much area and tell 2/3 base into it. Complete nonsense. This is nonsense. Make a note. Anyway, in the YouTube class, I will make further more effect, because why? I will prove there it is wrong. Now fully clear? Full clear or not? Now question is over. Full clear? If full clear means I will go to problem now. No. Is the question fully clear? So far what I told. Okay, now one more important. See, we need not only area, where is CG? Remember, If you take the full area, CG is here. Now, where is CG if you consider half the area? That I will prove in the YouTube class. Why? Actually, earlier, last time class for cantilever, I told 1 and 3/4, 1 and 1/4. That I proved. But now, that proof I will not do here. I will give a formula. You have to believe me. You have to believe me. No other way. I can be believed. Don't worry. See, now, if you consider this way, this is the height means maximum height for the BMD. Means this is nothing but what? This is going there. See, this cannot go there. This cannot go there. Base is B. One thing is sure. See, area equal to 2/3 of base into height. Okay. 2/3 of B means base. Base into maximum height. Okay. Now, if it is a straight, see, if you remember, if the parabola is this way, or if it is a triangle, see now, if parabola is this way, CG will be here. Anybody can tell me this number? I told you for cantilever parabola, this number. I told you. Repeatedly used in the class 100 times. That number, first. I do not know how many times I used it in the class. I used it so many times. First. What is that number if the curve is this way? That is for cantilever. 3/4. 3/4. Remember, 3/4. If it is triangle, CG will come slightly this side. Tell me, if it is triangle, this number, first. Today class I will give all principles. Then I will solve this question. Okay. If it is triangle, 2/3. Now, why? CG will come this side. Now, tell me, if it is a triangle, CG will come here. Because of this parabolic effect, will CG will come further this side, left side or right side, compared to triangle? If it is this type of parabola, see, now when you put the area this way, that side also area increases. But area increases severely on left side. So CG will slightly shift to which side? Tell me. Left or right side? CG will slightly shift to which side? From here, slightly shift to from triangle compared. For little this side, left side or right side for this diagram. No, left side, not right side. See, if it is triangle, 1/3, 2/3. Because of this area, extra area is more severe on this side. See there, that side is gaining little extra area. This side is gaining more extra area. Therefore, tell me, now tell the answer. This side is getting more extra area. Therefore, left side, remember, for this triangle, if I take triangle here, slightly this side. This is the CG. Remember, from here and here, formula is there. In the RCC class, limit state method, when I derived the stress block parameter, I told, remember, this you have to remember, no other way. So, this is 3/8. This is 5/8. One thing guaranteed. CG is little that side. Why? See, one thing guaranteed. What? More area that side. So for entire area, see, triangle. This is 2/3 means what? It is 0.6667. This is 0.625. Slightly this side. So this is 3/8 of base. This is 5/8 of base. This is 3/8 of base. Or if the triangle, if the parabola is this way, remember the CG location distance is See, if it is this way, 3/4. If it is straight line, what? 2/3. If it is this way, 5/8 from here. Here number is 3/8 of base. Fully clear means tell me, I will start the question. If this is fully clear means I will start the question. If concept is fully clear, I will start the question. If it is fully clear, fast. This all you have to remember. This, see, I nearly took half an hour for explanation. People will tell me no time. See, area is 2/3 base into height. They won't put the conditions all. You are not telling. Clear means I will go to the problem. First, one comment clear. From here, which is bigger you can make out. CG will be slightly that side. See, more area here. That parabola this way means 1/4. Straight line means 1/3. Now it is 3/8. Or from here, parabola this way means 3/4. Straight line means 2/3. This parabola 5/8, provided your area is up to center. You cannot stop here and do it. Clear? Okay. Now make a note. Make a note. Some people, what they do is, they cut, if this is the curve, see, curve, this is the midpoint. They consider only this much area. They will take this height and base. Suddenly looks like correct. They will write area here also 2/3 base into height. They will write this CG at 5/8b, this CG, they will write 3/8b. This is mathematical blunder or nonsense. This is not allowed. Not allowed. I will tell you so many people, to be frank with you, I do not want to tell where. Highly reputed place. I have seen they took up to here and wrote 2/3 base into height. I got the shock of my life. I thought that I won't name that much reputation and this area 2/3 base into height. In the YouTube class, I will show you wrong. Or in our question also, I want deflection somewhere here. Not here. Numerical problem. I want deflection somewhere here. Then you need that much parabola. You apply the formula. See what happens. Before I start, I will give you the answer. I will give answer by Macaulay's method. Or once I give the answer remains same. All of you got confidence in me. If I tell you do any method, deflection here is, I will tell 600 by EI. Nobody in the world can change it. It will be 600 by EI only. But when you do this way, it will give wrong result. Then I will tell what is the mistake. That is tomorrow, not today. But for that, today I will finish this question and do the numerical. That special question I will take tomorrow. Agreed? Tomorrow I will write concept-based class. I will put heading there. Important concept-based class for area of a parabola. I will put some statement I will write there. Concept-based class. So that today I want to finish everything now. Okay, now start. See, these all remember, I told you, mathematics is so powerful, people should understand. When mathematics is, something is there, on what conditions it is derived. Not blindly put everything without thinking whether applicable or not. Last class, cantilever, I told you. Dividing, see, I told you earlier, if a parabola comes this way, suppose you divide like this is a mathematical blunder. I told you. So, start. Now, come back to our question. Fresh start now. Start fresh. Yes, now question starts. Simply supported beam of span L, subjected to UDL of intensity W per unit length over entire span. Please find maximum slope and maximum deflection. Required what? Required is what? What is required? Required maximum slope, that is theta maximum, and maximum deflection. Deflection, that is y maximum. Okay, start. First draw the beam. 0, 0 BM here. Mark the center here. You write center. And you know BM 0, BM 0, center BM is WL square by 8 over. Draw the elastic curve. Draw the elastic curve. As usual, elastic curve always I use blue color. Why? To make out the curve. See. Somewhat as neatly as possible. See, this is the point A. A will remain there only. This is the point B. But your C will come here. See, if I draw a tangent at C, it will come like this. This is tangent at C. Then, here also tangent at C. Theta C equal to 0. This is your y at C. And now, this is A. Okay. Now, draw a tangent here to elastic curve. This is your theta B. Draw a tangent to elastic curve here. This is your theta A. And one more thing, I already told 10-15 times, if people don't follow the class, suddenly come to the class, tell not clear, I am not bothered about them. Study every class. I told very clearly, this is what? This is displacement of A with respect to tangent at C. That itself is YC. Yes or no? Remember, hundreds of times told earlier. Displacement of A, tell me yes or no? Hundreds of times told. If you tell yes means, I will start the question. One yes required. Displacement of A with respect to tangent at C. Okay, start. Now, I will not waste time. First, theta maximum. Simply supported beam, it is either theta A or theta B. Whichever is maximum. Whichever maximum. But due to symmetry, your theta A equal to theta B. Therefore, find any one of them, find theta A. Okay, now, to get theta A, apply Moore's first theorem. Moore's first theorem. Consider the point A, consider which point? Consider A and center C. Okay, now, what? Then slope at A minus C, slope at A minus slope at C equal to area of BM by EI diagram between A and C is the answer. Theta C equal to 0. Or therefore directly you get theta A. Why? Theta C 0 equal to area of BM by EI diagram between A and C is this area. Oh, formula. Tell the formula. For straight line, half base into height. For this way curve, 1/3 base into height. For this way curve, tell the area formula number. Area number. Area number. For this way curve, area number. Provided from support up to center. Do not stop in between. Area number. First. 2/3. Okay. It is 2/3. Thoroughly told of base L/2 into height is WL square by 8. Divided by EI. Okay. Just to understand correctly, the 2/3, remember, is a number. You have to remember it now. 2/3 is the formula. Tell the answer. Answer. There equal to WL cube by, if you remember Macaulay's method, tell the number. WL cube by number. You can see there. Entered 16, 16, 48, 24. WL cube by number. 24 EI. Yes. 24 EI. Over. Right. Therefore, theta A equal to WL cube by 24 EI clockwise. Due to symmetry, theta B also equal to WL cube by 24 EI only. Or see, area from here to here. But anti-clockwise, I told you 1,000 times. Rotational symmetry is always anti-clockwise. See, this is called dancing. This is not called dancing. Okay. Over. Therefore, maximum slope for the beam equal to WL cube by 24 EI, where at supports. Over. This is an important question for objective question. Okay, now, next, to get maximum deflection, Y maximum, we'll do, Y maximum, right, due to symmetry, Y max will be at center, that is C. Therefore, your Y max equal to Y at center. Note, to get to Y at center, find what value? Directly YC you can't get. Find Y of A with respect to tangent at C. 1,000 times told, right? Displacement of A with respect to tangent at C, that is called Y. A is the first point, equal to moment of area of BM by EI diagram between A and C, about which point? Tell me. About. When I find Y of A with respect to C, YAC, moment about which point? Again told 100 times. Moment about A. Moment about A. Be careful. Moment is about A. Here A. Okay. Equal to, start, area of the diagram. Area is 2 by 3 of base is L by 2, height is WL square by 8 EI is the area, multiplied by, we want moment about which point? We want moment about A. Its CG will be somewhere here. CG is here. Tell me, from A up to the CG is this distance. Remember, it is a bigger or small. See, I told you, for this type of parabola, 3/4, 1/4. For this triangle, 2/3, 1/3. For this parabola, one of them is 3/8, other is 5/8. Tell me, from here to here is 3/8 or 5/8? 3/8 or 5/8? First, 3/8 or 5/8? 5/8. Remember, it is 5/8 of base. What is the base? Of L by 2. Remember, later when you go to conjugate beam method, at that time, I want moment about C. Remember now, when I go to conjugate beam method, we want moment about C. Tell me at that time number. If when I go to conjugate beam method, in that method, moment is required about C. Tell the number for conjugate beam method. Later for conjugate beam method, tell the number. It is 3/8. Okay, over. Divide by EI. Now, why waste time? Take your calculator. 2/3 into 1/2 into 1/8 into 5/8 into 1/2. Do not take the calculator. You know the number. Tell the number. You know that number. Why you waste time? Waste calculating it. 5/384 equal to 5/384 WL power 4. Why? L into L square into L by EI. That is YAC equal to YC equal to Y maximum. Therefore, maximum deflection for the beam deflection equal to 5/384 WL power 4 by EI, here downward here at center. Fully clear this question? Fully clear or not? First, if fully clear, I will go to the trouble question. Clear? Okay. Now go to second question. I do not want to rub anything now. See, second question, available space, I will write here. Question 2. A simply supported beam of span, say 12 meter, of span 12 meter, is loaded by an UDL of intensity, say 20 kilonewton per meter over the entire span. Question is, find maximum slope and maximum deflection. And also, this also will be tomorrow. Why concept? Also, slope and deflection at one random point at 4 meter from ends. That is either here or here. Okay, start. This is the trick. See, this is where people make the mistake. Okay, start. Now, first, today I will finish maximum. Okay. EI I am not giving. Today time is not there. Next time remind me, I will give numerical EI. Okay, start. Start solution. Instead of wasting time. 20 kilonewton per meter. Span is 12 meter. Half is 6 meter, 6 meter. No L now. Bending moment is 20 into 12 square divided by 8. Tell the answer. 20 into 12 square by 8. Fast. Looks like raining now. Little fast give the answer. Before the rain hits, I want to stop. Slowly, sound started. 20 into 12 square by 8. 360 is the answer. 360. Okay, 360 is the answer here. Or you can remember 360 here. Okay, now. All this will remain same. No change. Right once again. But when you do theta A, 2/3 of 6 into how much? 360. Fast tell the answer. Answer. 2/3 of 6 into 360. Answer fast. 2/3 of 6 into 360. Numerical problem. 2/3 of 6 into 360. Bega bega. Don't waste time. 1440 by EI. 1440 by EI. Therefore, your theta A equal to 1440 by EI radian clockwise. Symmetry, theta B equal to 1440 by EI radian anticlockwise. So, maximum slope is 1440 by EI radians at support. Over. Y max, same way. 2/3 of 6 into 360 into 5 by 8 of 6. Answer. Fast. Answer. 2/3 of 6. See, this area. 2/3. You write once again everything. Those who are serious, make a fair copy. Write once again everything. Don't adjust like this. 2/3 of 6 into 6, 360 by EI. If you give fast answer, before the rain hits, I can close. Slowly rain started. 5400 by EI. It is 5400 by EI. So maximum deflection. That YAC itself equal to YC equal to Y maximum. So maximum deflection equal to 5400 by EI meter down at center. Tell me, is the question fully clear? Fast tell me. Is the question fully clear? Yes. Now, tomorrow's agenda. See, tomorrow, I write here, not today. It will take at least half an hour. Tomorrow, I will find that extra, that is what? Slope and deflection at 4 meter from one of the ends. I will tell now itself for this question, whoever solves theta max equal to, see formula, 20 into 12 cube divided by 24. 1440 number should come. Y maximum 5 by 384. EI I am not writing. Okay, EI 384 into 5 by 384 into UDL 20 into 12 power 4. 5400 is Y maximum. Already we got by EI. And tomorrow at 4 meter from ends, from any end, theta and Y, I will write now only how much should come. Taking a risk. I am not doing moment area. Today only I will commit, so that those who are serious, can you try? At least think. See, theta should come. Theta should come 693 or children is coming. Okay. 693.333 by EI is the slope tomorrow. I will check once again. Correct. And deflection should come 4693.333 endless threes by EI. My commitment for tomorrow. But if you by mistake, over, today's class over. Some people what they will do is, they will consider 4 meter here. And they will find this ordinate, The answer will be how much? Bending moment there. 120 into 4 minus 20 into 4 square divided by 2. The ordinate is 320. Then they will tell area equal to 2/3 of 4 into 320. Calculate. 2/3 of 4 into 320. Calculate. 2/3 of 4 into 320. Calculate. 2/3 of 4 into something they will write. What is the answer? 2/3 of 4 into 320 they will calculate. 853. But what is the slope I have given? What is the slope I have given? No, what is the slope I have given? What is the slope I told today? I will check once again now. What is the slope answer I told? Remember, I told. Slope answer I told. 693. When I tell 693, if some other procedure gives you 800, then who is wrong? That is wrong. I will check once again. Why? No chances to be taken. Yes, 693 point something is correct. So, at least those who are serious, see, this is a mathematical blunder. Considering the parabola from support up to any other point, then you cannot apply the formula that 2/3 or 5 by 8. You cannot apply. You can apply 2/3 or 5 by 8 or 3 by 8 only for the parabola, for UDA only, from support up to center. Should not stop in between. Clear? Clear or not? Raining heavily. Should not stop in between. Clear concept? Concept clear or not? Fast. Okay. Now, those who are serious, at least can you try? Remember, you have to go to integration principle, or there is a shortcut invented by me only. There is a shortcut invented by me only. One day, when I was thinking, if integration difficult, suddenly the idea came to me. I will let you know tomorrow. Okay, see, rain started. Luckily today, no disturbance. Slowly rain is becoming more and more. Okay, try. See, FPM class, 9:15 is there. If thunderous rain comes, I will write in the board today. Very heavy rain, I will put a message there. Hope by 9:15, rain will stop. I sincerely hope that rain will stop. Okay, thank you. See you tomorrow. I will give you the real mathematical feeling or mathematical concept for this area. See, all such mathematical concepts, some will ask, sir, what is the use? What is the use of? If you learn such concept, your knowledge level will go very high. Then any problem you can tackle. It is not that, sir, nobody wants deflection here. Correct. Somewhere else, mathematics will never let you down. Okay, thank you.